Hello and welcome to our meteorite presentation. Today we will be discussing how a site can be determined to find Vesta or HED meteorites in the Antarctic.
This is the Vesta Meteorites Team.
Our main goal was to make a climate conscious project and poster to summarize our work and research. Our objective for this research project was to find the best site in the Transantarctic Mountains in Antarctica for the ANSMA team to go to collect HED meteorites. HED meteorites are thought to originate from Vesta, an asteroid located in the main solar system's asteroid belt.
HED stands for howardite, eucrite, and diogenite, which is the name of different types of rocks found on the Vesta asteroid. Furthermore, achondrite meteorites are a type of stony meteorite. The Antarctic is the best place to find meteorites for a couple of reasons. 1. The cold and hyper-arid weather preserves meteorites. 2. Ice sheets provide a focusing mechanism for meteorites. 3. Meteorites stand out on ice. Lastly, and most importantly, in the Arctic, meteorites are untouched by humans. In the end, meteorites fall randomly and cannot be predicted where they land on Earth. But what can be predicted is how the ground and environment moves meteorites to semi-predictable locations where scientists can then find them. Specifically, we found that the HED meteorites are affected by ice sheets.
To determine the best location for collection, we calculated and located all known meteorites discovered by ANSMA, as well as factored how ice sheet movement could affect the number of meteorites found. The work was divided evenly among group members, and the poster and presentation were put together with the data collected.
Data for the two graphs came from an official ANSMA source that regularly updates meteorite finds. Bar graphs were used because they efficiently show data visually. The amount of each of the three types of HED meteorites were totaled per site, then summed to show the total number of Vesta meteorites per each site. The graph comparing the total number of HED meteorites per site shows that Miller Range had the highest amount of meteorite finds, and Elephant Moraine was a close second. The graph comparing the total of each of the three types of HED meteorites per site shows that Miller Range had the most evenly distributed amount of types of HED meteorites, though Elephant Moraine had the highest amount of howardites and eucrites, and Miller Range had the highest amount of diogenites.
The reason why some sites contain more meteorites than others is due to the movement of the ice sheets. Layers of ice are formed through the annual cycle of snowfall and melting, which bury meteorites that land on the surface. Ice movement starts in the East Antarctic and slowly moves towards the sea. As they move, they carry with them buried meteorites, and when they come across a mountain range, they get uplifted and reveal the meteorites trapped within. Shown here are three sites that have similar geologic locations in relation to the Antarctic mountain range. They are small mountains found before the main mountain range. Elephant Moraine and Miller Range both have high abundance of meteorites. The reason why Mount Howe does not have as many meteorites as the other two sites is because of how deep it is in the Antarctic, causing it for it to be more dangerous to be explored. We believe if more exploration would be done in the area, more meteorites would be found, specifically HED.
Based on the implications and findings of the conducted research, it is recommended that the ANSMA team search the Elephant Moraine and Miller Range sites for Vesta or HED meteorites in general. Furthermore, smaller mountain ranges off of the main range have shown to be promising places to search as well. To go more in depth, recommended sites can also be determined for each separate meteorite type. For howardites and eucrites, the Elephant Moraine is shown to be the most prominently spotted region, while diogenites are more common in the Miller Range. It is also recommended that future ANSMA teams search at Mount Howe and other deeper places in the Antarctic.
Conclusion. Overall, the findings were that Miller Range and Elephant Moraine have the highest amount of HED meteorites. Elephant Moraine contains the highest amount of howardites and eucrites, whereas diogenites are most likely to be found in Miller Range. Ice sheet movement. As snow layers on top of more snow, pressure builds up and turns into blue ice. As more and more snow layers, the ice sheets get pushed away from the East Antarctic into each direction. These meteorites get trapped in the ice and are carried to outside of the continent and stop at the first mountain and get uplifted. As snow gets uplifted, so do the meteorites, causing for many HED meteorites to be found near mountain ranges. Benefits to ANSMA. We're providing a guide for the next ANSMA team with locations for where they can find Vesta meteorites.
We all really enjoyed the SEAS experience and opportunities given to us. Some challenges we came across were trying to match time zone differences, as well as dealing with technical difficulties. However, we are very grateful to be a part of this program and the skills it taught us, such as working together as a team and doing research. This program was a great opportunity that opened new fields for us to explore in college and our future careers.
Our team would like to acknowledge as well as thank Ms. Foxworth, Mrs. Kellye, Mrs. Baggio, Mrs. Miller, the NASA Texas Space Grant Consortium, all NASA area speakers, and contributors to the SEAS Speaker Series as well. These are our citations, and this is our poster. Are there any questions?